In section 1 of chapter 9, we looked at how a x bar is used to estimate mu. X bar is a point estimator. And once we calculate the x bar value, the actual value is called point estimate. Now in section 2, we look at the confidence interval estimate. A confidence interval estimate is a range of values constructed from sample data so that the population parameter is likely to occur within that range at a specified probability. The specified probability is called the level of confidence. So the confidence interval is equal to whatever value you get from the sample called the point estimate, then plus or minus a margin of error. To understand the margin of error, I just wrote something down here. If you recall first from the first video, to convert to z-values from a specific x bar or sample mean value, we use the formula z equals x bar minus mu divided by the standard deviation of the sampling distribution of x bar, which is sigma over the square root of n. But the margin of error is defined as the difference between the estimated value using the sample of mu and the actual value of mu, which most likely we will not know. But this is the definition of the error of the mean or the margin of error. And solving in this formula for x bar minus mu, we just multiply by sigma over the square root of n on both sides, and we will get n. So therefore, the margin of error is equal to this. So that is the margin of error we're going to use in our confidence interval estimation. The z value here is determined by the level of confidence. And this is the standard error of the mean, or the standard deviation of the sample means. The two together, once we multiply the two elements, we get the margin of error. Let me skip this one. So the margin of error, the confidence interval is equal to x bar plus minus z times sigma over the square root of n. The point estimator of the population mean, which is the sample mean, plus minus the margin of error. For a 95% confidence interval, about 95% of similarly constructed intervals will contain the parameter being estimated, in this case the mean. Also, 95% of the sample means for a specified sample size will lie within 1.96 standard deviations of the hypothesized population. Let me explain what that means. A 95% level of confidence means that 95% in the normal distribution will be in the middle of the distribution. So that on the left-hand side, let me show you that here, 95% level of confidence using z-values. And remember, this is 0. So 95% will be right in the middle. That means that 5%, the remaining 5% will be on the right-hand side, but divided by 2 because there is also a left-hand side. So the 0.05 will be equally distributed on the two tails. between the two tails. So by symmetry, the area under the curve between 0 and this value should be 0.5 divided by 2, which is 0.475. And this area by symmetry, of course, is also 0.475. And if you go to the table and look for an area of 0.475, then that corresponds to a z-value of 1.96. And of course, by symmetry, this value here is minus 1.96. And you can also use Excel, as I have shown you before. What is the area between 0 and, what is the value of z for a given probability? Well, remember that in Excel, you just look at cumulative probabilities. So the area to the left of this z-value is equal to 0.95 plus 0.025. So if you have 0.95 and add 0.025, you get 0.975. So it's all the cumulative area to the left of z. So in Excel, the area that we need to specify is 0.975 cumulative. All right, so let me type first, norm, and we're looking at s.s. And since we are not trying to find a probability, we're trying to find a z-value, we need to use the inv command, inverse. And in parentheses, we just have to specify the cumulative area, or the lower tail area. Close, enter. Notice the value will be 1.96 approximately. All right. For example, the American Management Association surveys middle managers in the retail industry and wants to estimate their mean annual income. A random sample of 49 managers reveals a sample mean of 45,420. So this will be our point estimate. The standard deviation of this population is 2050. So notice this is the case when we know sigma. And so sigma is 2050, x bar is 45,420, and n is equal to 49. What is the best point estimate of the population mean? Well, it is 45,420. What is a reasonable range of values for the population mean? Well, we need to develop a confidence interval. And what do these results mean? What is a reasonable range of values? Well, you need to use the formula. Confidence interval is x bar plus minus z times sigma over the square root of n. The value of z is the one that you need to specify for a given confidence level. And this is added here. Suppose the association decides to use the 95% level of confidence. Well, we already know that the z-value that corresponds to 95% level of confidence is 196. 196 to the right and minus 196 to the left. This is a portion of your table. How is that you find the 196 value? First, on the left-hand side, you go down or read down the table and stop just before the value of 0.475. Remember, the area between 0 and z is 0.475. So as you go down, notice the value here exceeds 0.475. So you stop here and then move to the right. These values are going to increase. And right here you have 0.475. And the value corresponds to a z-value of 1.9 plus 0.06, which will make it 1.96. So our confidence interval will be equal to 45,420, the sample mean, plus minus 196 times the standard deviation of the population, 2050, divided by the square root of n, which is 49. So once you do that, you get 574 as your margin of error. So the confidence interval limits are 44,846 and 45,994, which you can obtain from adding 574 to 45,420 and then subtracting the same number, 574, from 45,420. The degree or level of confidence is 95%, and the confidence interval is from 44,946 to 45,994. The $574 is called the margin of error, plus minus. What is the interpretation of the confidence limit between those two values? If we select many samples of 49 managers, because we are using only one sample, and for each sample we compute the mean and then construct the 95% confidence interval, we could expect about 95% of these confidence intervals to contain the population mean. Conversely, about 5% of the intervals will not contain the population mean annual income, mu. Well, here on the graph, you see there is an x1 possible that you may get from a sample. You may get a value of x2 or a value of x3, all of them x1 bar, x2 bar, indicating sample means. Here you have an x bar 4, x bar 5, x bar 6. You don't know where your sample mean is going to be in the distribution of sample means. But it could be this or this or this or this or this. If you notice, if you obtain the value here and you add and subtract your margin of error, in your range, you're going to include mu. For x2, you included 2. For x3, you included 2. For x4, you included 2. For x5 would not be included, it would be too far to the left. For x6, obviously, is included 2. So when do we obtain values like x6, x4, x3, x2, and x1? Well, all of them bars, of course, sample means, 95% of the time.